We are in section 6.1, which will begin our study of factoring. We'll start with our first type of factoring, which is the greatest common factor. The greatest common factor of two or more integers is the largest integer that is a factor of the given numbers. So in our first example, I ask you to find the greatest common factor of 24 and 60. So what we can do is start by listing all of the factors of 24, and they're easier to list in pairs. So you could say 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And those are all of the factors of 24. You can also list all of the factors of 60. So the factors of 60 are 1 and 60, and 2 times 30, and 3 times 20, and 4 times 15, and 5 times 12, and 6 times 10. There are lots of numbers that are common to both lists, but when we're looking for the greatest common factor, we want the biggest number that resides in both lists. So 1 is common, 2 is common, 3 is common, 4 is common, 6 is common, 12 is common. But the biggest one that's in both lists is the number 12. So the greatest common factor of 24 and 60 is 12. Now we want to expand our common factor examples to include variables as well. So the greatest common factor of two or more exponential expressions with the same base is the one with a smaller exponent, because smaller means that they would have them in common. So I ask you to find the greatest common factor of 9x squared y z cubed and 30x y z squared. First of all, we have to find what 9 and 30 have in common. So 9 has the factors 1 and 3 and 9, and 30 has other factors. But the factor that's in both lists would be 3. So both numbers have a 3 in common. Each of the expressions has an x in common, but the smallest x, going back to the definition, the smallest x would be x to the 1. Both terms have a y in common, but the smallest y is y to the 1. Both terms have a z in common, but the smallest z is z to the second. And so your GCF would be 3xyz squared. So we want to put that together and actually factor out the greatest common factor of these examples. Our first one is 12a to the 5th b squared plus 16a to the 4th b. Let's look at the numbers first. 12 and 16 both contain a common factor of 4. They both have a's, and the smallest a would be a to the 4th. They both have b's, and the smallest b would be b to the 1. So the greatest common factor is 4a to the 4th b. So we have to open our parentheses to see what's left. We have to put in the parentheses what remains. So 4 times 3 would give me the 12. I have an a to the 4, but I need an a to the 5, which means I need one more a. I have a b, but I need a b to the second, so that means I need one more b. My sign is plus, so I'm going to keep it and go to the next term. 4 times 4 gives me 16. I already have a 4, so I don't need any more a's. And I already have a b, so I don't need any more b's. And so my final answer is 4a to the 4th b times parentheses 3ab plus 4. Looking at our next one, we have 9x squared plus 15x to the 4th. 9 and 15 have a common factor of 3. I notice that both terms have an x, but the smallest x is x squared. So the greatest common factor is 3x squared. We'll open our parentheses to see what's left. 3 times 3 gives me 9. I already have an x squared, so I don't need any more x's. My sign is plus. 3 times 5 gives me 15. I'm needing 4 x's and I already have 2, so that means I need 2 more. So my answer would be 3x squared times parentheses 3 plus 5x squared. Our third problem is 6x to the fourth y squared minus 9x cubed y squared plus 12x squared y. Looking to see what they have in common, 6 and 9 and 12 all share a common factor of 3. I notice they all have x's, and the smallest x is x squared. They all have y's, and the smallest y is y to the 1. We can open our parentheses. 3 times 2 would give me 6. To make 4 x's, that means I need 2 more x's, and I need 1 more y. My sign is negative. 3 times 3 would give me 9. I need 1 more x and 1 more y to make 2 y's. Going to the last one, that would be a plus. 3 times 4 gives me 12. I don't need any more x's. I don't need any more y's. So that would be my final answer. 3x squared y times 2x squared y minus 3xy plus 4. Okay, so we have some little ones to do, and then we'll be done with this concept. My next problem, factoring out the greatest common factor, is 5x squared plus 30. What they have in common is a 5. They do not have x's, so there is no common x factor. All we can take out is the 5. What's left would be an x squared. Taking 5 out of 30, that would be a 6. So what we have in common would be a 5, and then what's left over is x squared plus 6. Our last one is 4x squared plus 2x. 4 and 2 share a common factor of 2. I see that they both have an x, so we could take out an x to the 1. Writing in what's left, we'd have 2 times 2 gives me 4, and I need 1 more x. For my second group, though, I have to have a placeholder, so I'm going to carry over my plus sign, and then I know 2x times 1 would give me the 2x. So I have to put the 1 there. Remember that you can check these by multiplying through. If I didn't have the 1 there, then I wouldn't have that 2x in the back. For example, if I checked this one, I would get 4x squared, and if I didn't have the 1, that would be what was left. But I do need the 1 because 2x times 1 would give me 2x, and 4x squared plus 2x was the problem that I began with. So the 1 must go in this place to hold, 1 must go there to hold its place. Your final answer for this problem would be 2x times parentheses 2x plus 1.